Hello friends, welcome to my channel. Today I shall show you some techniques, some problems regarding Laplace transformations. So the topic is Laplace transformation. Suppose we have one function f of t. So this is the function. If we carry out Laplace transformation of this function, then we can write like this. This is given as integration 0 to infinity e to the power minus st ft dt. Clearly you can see this function becomes this result becomes one function of s. So this is the Laplace transformation of function ft, provided that this integration exists and s is the parameter. So we can write this as Laplace transformation of ft as like function of fs, and if we want to get back this ft, we have to carry out the inverse Laplace transformation, which we can write like this simply. So these are the basic things for performing the Laplace transformations. So before proceedings, we have some elementary functions, like some integrations which you can carry out yourself also, like L of 1. This is what will be the value of this. So if we carry out this Laplace transformation like this, so it will be to the power minus st, ft will be 1 here. So this is e to the power minus st dt integration 0 to infinity, and this should give 1 by s. And if we carry out the Laplace transformation of one function like t to the power n, then the value will be factorial n divided by s to the power n uh, plus 1, with n is equal to 0, 1, 2, 3, 4, and so on. If we have function like e to the power 80, so e to the power 80, then we can get the result like 1 by s minus a. Laplace transformation of sine 80, say, will produce result like this. These are some standard integrations and results. If you can remember, is fine, otherwise is okay. So cos of 80, uh, Laplace transformation of this function will give you this. So you see, for sine we have a, and for cos we have s here. And let's take some hyperbolic function of sine h 80 will give you a square minus a square, and for cos, Laplace transformation of cos hyperbolic function of 80, it will be s square minus a square. So with this, let's verify some results. So if we can check this Laplace transformation of 1, that will be, as I mentioned, 0 to infinity integration e to the power minus st dt, and 1 is there because ft is 1 here. So this will give you e to the power minus st divided by minus s, and this is our integration limit. and you can easily get 1 by s if s is greater than 0. Now if we check this Laplace transformation of t to the power n, what we can find, we can write like this. So uh, we can simplify this by assuming st as say p. So then we can write this. We have assumed where we have assumed st is equal to p. So this will be like this. This is a gamma function. You remember gamma function, gamma function. So we use this gamma function as like this, gamma n plus 1 divided by s to the power n plus 1 if n greater than minus 1 and is greater than 0. So we can say, like, suppose uh, we want to find the Laplace transformation of t to the power minus half. This is a particular case. Then what will happen? You see, this is the formula for us. So here n is minus half. So gamma n is minus half plus 1 divided by s to the power n plus 1. So minus half plus 1 is mm, half. So this is gamma half divided by s to the power half, and gamma half is root pi. So we can write it like this, root over pi by s. So hope you have understood. Now if we uh, want to carry out the Laplace transformation of a function like t to the power half, like root t, then what will happen? So n is equal to half here. So gamma half plus 1 and s to the power half plus 1. So this is gamma 3 by 2 uh, divided by s to the power 3 by 2. And you know gamma n plus 1 is n gamma n. So this is basically uh, gamma 1 plus half. So this is 1 times gamma half, that is we can write just root pi, because gamma half is root pi to the and divided by s to the power 3 by 2. Yeah.